9702 February March 2018 paper 1 variant 2. The question is for the inclined plane and the dynamics. A car of mass 1100 kilogram is traveling at a constant speed of 15 meters per second up a slope inclined at 10 degree to the horizontal. The combined frictional force acting on the car are directed down to the slope and are equal to 5 W over 5, and where W is the weight of the car. What is the useful output power of this car's engine? So we need to find out the output of the car's engine. Means we need to find out the driving force, the power which actually came from the driving force. So we need to find out the driving force first. So first thing first, it says the frictional force. The frictional force is the W over 5, which is weight of 5 over 5. So first we find out the weight. Weight is 1100 times 9.8, 108780 Newton is the weight. So W over 5, which is 10780 divided by 5, which is 2150 Newton, right? So next, the car is moving upwards. That means the vertical component of the weight of the car is we need to know first. So the weight of the vertical component is 10780 sine 10 degree will be 18782 Newton, right? So next, what is the driving force? Driving force is the sum of the the vertical component of it, because the driving force used to overcome the frictional force and the driving weight of the vertical component. So 1872 plus 2156, which is 4028 Newton, is the driving force, right? So this is the driving force. Now, uh, what is the useful output power of the car's engine? So power is equals to force in times velocity. Velocity is constant, speed is constant, so we will use this formula. Power equals force times speed. So force is the driving force. So the driving force, which is 4028. So 4028 times 15, if we will get 60420, which is approximately 60 kilovolt. So C is the option. So what is the catch in it? The problem is the formula. We know the whenever we have a constant speed and we need to find out the power, the formula is force time speed. So force, what is the force here? Force is the driving force which is actually used in to overcome the weight and the uh, frictional force of the body. So net force will be the driving force, right? So will be the vertical component of the weight. So the total driving force will be the driving force will be the sum of frictional force and the vertical component of the weight of the car. So this is the main catch of this question. The net driving force is equals to the sum of the frictional force plus weight, vertical component of the weight. We understood the car is moving upward, right? And the weight is actually is here, right? So that means driving force, which is actually makes some confusion. So I will write this. Uh, Driving force is compensating these two forces, right? And for by this there is the net force is, you can say, the zero. That means the speed is constant. So driving force is equals to the sum of the frictional force and the vertical component of the weight. So this is the main catch of this equation, or you get, sorry, the problem.